Today it's a DNT base station, which is effectively an M40 with some different component values bolted to a power supply. So this is coming from the trade. It wants a power supply rebuild. These are, if I recall rightly, the crystal filtered as standard, and it's just kind of longer with the mains lead coming out. It's come with a microphone, which is a DNT microphone. There we go. Right, so we'll open it up and not touch the set, but rebuild the power supply first. If I recall rightly, my screwdriver doesn't fit these types of screws. Time for the backup screwdriver. Oh dear. So they're all going to have to come out. Oh, can't get them out with this screwdriver. Oh, this is going to be a short video, isn't it? Wow, that one was loose, that's good. That's 4 out of 8. See if there's anything on the bench behind. Not really. Okay, so we've borrowed a red Aldi screwdriver instead of a branded one off Mr. Chippie's bench. It's probably the nicest condition one of these I've seen for decades. Let's just hope there's no dry joints and the actual radio works, because as you know they're difficult to set up with the multi-crystal mixer arrangement. Good grief, it's like a rat's nest in there. Straightforward power supply, bridge rectifier, regulator device. What is it? L7812 CV. I think it's the slightly upgraded 7812. So what we have to do is to get this board out and get to these capacitors. What fun! Does our normal screwdriver kind of fit? No, of course it doesn't. The trouble is, they've gone and put sealant on. I'll pause the video. Right, so we're back on with this. Kind of got the printed circuit board enough by moving one side. So we've got 1000 at what's probably 25 volts. And 2200 definitely at 25 volts. Nicky Den, I think that's a kind of knockoff of Nicky Con. So we're putting Nicky Con in. We've got 2200 at 35 volts, so we've got an improvement there, 105 rated. And we've got a Jackson one, which is another good brand. These are actually very expensive from RS. 105 degrees, and it's 25 volts. So, sorry, it's 35 volts, because I couldn't read whether that was 25 or 35. We're putting 35 in. So we've got quite a small chain, you know, with size. The other side of this is I'm putting 105 degrees in because it's in an enclosed compartment. Now, these probably work fine, but I'll tell you what, we'll test them. to short that out just in case it's got any charge in it. I mean, I haven't powered it up, as you know. Let's just put this on. Well, it's reading 1000 microfarads, so we can chuck that one away. Just make sure that's discharged. The point is, these are 40. This has got a bulge in it. They're 40 years old. That's reading high. That's starting to be indicative of failure, because we're not testing for voltage here. It may well be that it breaks down anywhere near its working voltage, which is what often happens. 1000 is probably still working and the other one not so. Okay, so we've got that back together with new capacitors in the power supply. So do we dare to turn it on? We do, and we are lit up. Let's check the voltage. I think the 12.8 volts or something like that. They're not 13.8. So 11.95. So it's non-adjustable. What you get is what you get, but it doesn't affect the performance because the circuitry is designed to work at this lower voltage. We'll plug the mic in and we'll plug some of the test gear in. I've got that grommet to put in yet. So on this set, the radio, this power supply is on all the time. So whilst ever the radio is plugged in, the power supply is running. So just be aware of that. And it's going to be using some electricity, isn't it? The on and off switch is just low voltage. FM hiss. Let's put picture in picture on. See if we've got transmit. We have got transmit. Hopefully it's low power. That's high power. It's doing 3 watts. So the first thing, I'll put it back to low power. The first thing we need to do is set the 10.7. What am I talking about? The first thing we need to do is set the 10.24 which I've got a circuit diagram hopefully here. So you can work on these quite safely because the mains is straight into all this shrouded bit of the transformer. Well, I've printed off the circuits, I've printed off a sheet to write all the things down on. I'm by the printer and nothing is there. So what's all that about? So is it time to restart the computer? Oh, all right. Where's the pen? Right, let's just run through this before turning it into a retune job. Could use the clipboard, it might be easier. I'm trying to get this finished in the next half hour, because otherwise we can't do an on-the-air test today. We're already about 20 past 7. It's showing as being spot on frequency, I'll show you that. But because it's tied in with the 10.24, I've got to double check and all that. So 2779121. It's whether the receive's on frequency. This is the problem. So yeah, that looks great, but I've shown these enough times anyway. It's not like I've never shown a DNT before. Right, we're on go to high power, and we are doing 3 watts exactly. Let's go to a different channel. Channel 40, 2.8 watts. Channel 1, usually get 4 watts out of these. Doesn't mean to say we will, but low power, back to channel 20. And without the bench power supply supplying the voltage, we've no idea what the current consumption is, which is a shame. Low power is a measly 80 milliwatts. Deviation, for what it's worth on this test set, wallow, 1.2. Now the VCO is either locked or not locked. It's not like the voltage you get on a Cybernet set. You monitor the lock detector pin on the general purpose synthesizer which it uses, the Motorola one. We've covered that before. So can I poke this up so you can see it? In transmit, it goes back to high power. In transmit, it's in the centre of the red zone, so that's correct. Let's go to receive and let's see whether it's actually receiving, or whether we're going to end up with a part 1 video and a part 2 tomorrow. I've got quite a queue of sets, so I'd like to get this back, but on the other hand I don't want to hurry it and not have it spot on. There we go. So we're on frequency. I'm putting it on frequency on purpose because we don't know where this is on frequency with having this multi-crystal mixer. So for 12 dB we've got a quite reasonable 0.92. Let's just go over to that instrument so you can see it. For 12 dB, for 10 dB we've got 0.74, and for 20, if it does it, we've got 0.9, no we haven't, we've got 3.1. squelch. Remember, these are pretty lousy on squelch. It's 3 microvolts maximum. And the sensitivity, let's go for that. Show you the attenuator. And we're in standby at 0.3 of a microvolt. Put the squelch on to minimum. Yep, signal generator back on, straight in 0.3. So it's sensitive enough, but it wouldn't be any good in a town as this is set. And the S meter should of course be S9 for 100 microvolts on a UK CB. It's a bit generous. And for S9, it's reading 38 microvolts. Meter lamp, da-dum, da-dum, da-dum. Doesn't have one of those. Da-dum. Right. We'll just do this first. To try and speed this up, I'm going to do this in the topsy-turvy order. I'm going to see whether the receiver's on frequency. I'll put 3 microvolts on the signal generator and I'm going to turn the tone off. We're putting a second signal generator on, cheap Chinese one, as a marker oscillator. So the IF on this radio is 10.695. It has a 455 IF as well. You can have a second signal generator on either, but it's easier to do it at 10.695. So, coming out, I've just got a BNC lead with a couple of crocodile clips on. So you don't connect this to anything. You just wave the hot in the vicinity of the IF. It looks like it's spot on, but I wouldn't expect that to be. Let's switch this off and back on again in case it's got its knickers in a twist. Oh, it's had, it's got its knickers in a twist. That's what I was waiting for. Okay. So be quite clear, on my signal generator I've got 2779125, which is the correct frequency. On this secondary signal generator I've got 10.695, so the only error can be the radio, hence the trimmer. Now it's spot on frequency on receive. Now I may have to do that a second time because I want to check where the 10.24 is. I'm just doing this to be quicker. I don't normally jump around like this. So we put the oscilloscope on, which I'm using as a frequency counter. If we look at the square kick diagram, synthesizer is pin 3 and 4 are the reference crystal between pin 3 and pin 4. So I might be able to do it from this side. Let's put that to chassis using a can. So what I'm looking for, oh, apart from pin 1. 1, 2, I'm looking for pin 3 or pin 4 to give me 10.24. I'll just turn this volume down, or it's going to be very annoying. 1, 2, 3. That's 50 point something. That's not solid. 10.23 something. Let's just set that auto. .2390. So it's very, very slightly out. Now this may be the best he can get. I mean, I don't know whether he hasn't been through all this. It's not stupidly far out that it would affect performance, but it'd be nice to just have it spot on. So let's see what we can get. I'll leave it there, 10.2399, and just see whether we can still get receive. So remember, nothing's changed on our receive. It's now going to be off frequency though. Put the tone on, just to prove it. Bring back the Chinese little signal generator. The audio multimeter doesn't like that, does it? Just trim this a second time. It's very close. But that's why I was doing it before and after, to see whether we could actually get if it was going to get receive and be on frequency, if it was going to get the 10.24, and now will it do the transmit on the correct frequency? So now it's high, can we bring it down low enough? Yes. It's a good example, this set, because some of this you've got to kind of have that slightly out to get this and that right, but this one is set up exactly on the correct IF. If you don't have the IF right, it's going to be lopsided on receive, and it's going to be sound crap, isn't it? Let's face it. So, considering it's 40 years old, that's a brilliant result. So that's the complication. Having to use a marker oscillator, having to juggle those. So normally you're supposed to do 10.24 first, and then we can do the transmit, and then we can do the receive. So now it's a straightforward tune-up. You know, the radio is working. Just see whether we can get a bit more than the 3 watts out of it. It really doesn't matter if we can't. Right, I don't know what the tune-up. I don't see enough of these, and I can't find any notes because I never seem to scan my results and file them away. So L1, L2, L3 the front end. Perhaps we ought to start with the detector. Looks to be like L4, L5, something like that. Let's put some tone on. We'll start with the receive first because it's not the nicest waveform in the world. So it's one of these, isn't it? It's both of those. And it's alright reeling off the numbers, nothing's labelled, is it? Okay, so let's now look at the cyanide meter. Now, putting it on frequency will have affected the results. I've just done the detector, and it's now less sensitive than it was when it wasn't on frequency. Drop the signal. Just out of interest, and let's just make the detector worse. Go back to an S9 signal, go back to the oscilloscope. So off camera I've just had to reset the 10.24 slightly low, because obviously something is lopsided on this, to get the sensitivity. And we're now at 0.9 something. So the fact it's right is now worse sensitivity than when it came in. But hopefully it won't sound garbled. Showing you the wrong screen. We've got a layout for DNT. We have got a layout. So we've covered L1, L2, L3. It says VCO. That's it as far as the receive goes. Okay, so back to the synod meter, and it's 0.96. It's just slightly worse. .79. But have we improved the 20? I think we will have done. Well, it's 3 for what it's worth. So whilst we're thinking about it, put 100 microvolts on the signal generator. Have we got S9? Well, that's what we need to be doing. I've just gone backwards again. I've just gone through it another 3 times, and we've got now for 12 dB 0.76 and for 10 dB 0.58 and has that made 20 worse? It hasn't, it's 2.5. So they haven't got time at the factory to do all this. Backwards and forwards and backwards and forwards. Let's see where we are for S9. There's S9, that's now too much. It's one of those two, isn't it? So there's our S9. Squelch. Just turn the volume down. Why can't I see squelch? Doesn't it have a squelch preset? Gonna be squelch. No, they don't have a preset. I knew there's something iffy. That's deviation, that's low power if I remember. Yeah, deviation, low power. Transmit meter, deviation, low power. Okay, they don't have squelch. I've just landed all the paperwork on top of the mic. So let's see where the squelch is now. Probably even wishier-washier. Let's go to the attenuator, full squelch. .6 microvolts. Yeah, it's even wishy-washier now, it's better. And the sensitivity, let's put it at... What you have got is this local... no, have you got local DX on this? Yes, you have, you've got local DX. That's how you get out of it. So if we had it on local and set full squelch, it now does 18 microvolts. That's how they get out of that one. Yeah, minimum sensitivity, let's go back to that with 0.3 I expect, just like it was before. It is. Okay, we're done with receive. Just do the transmit. I'm going to kind of start halfway because it's not like it's not working at all. So 3, 9, 10, 11, 13, 15, 16, 17. We'll start at 15. It's a broken core, but as long as it moves, we're going to be alright. So transmit, here we go. So we're going to be on the 30 watt scale. I'm not going to touch those two. Don't think we've got anything down there, and if we have, it's to do with the harmonic trap. I think that's where we are. Okay, behind the scenes I've just connected to the power supply just to make sure we can do more than the 1.5 amps this power supply does. The radio's drawing 1.1 amp, so we've got 3.5 watts, and it's hot, remember, the radio. But what is it doing on the other channels? Channel 40, the same. Channel 1, a bit lower. Low power, let's go back to channel 20. And low power, let's get it away from that 100 milliwatt. A bit dirty, that, isn't it? Do the power meter. It's supposed to be sent to the red zone. On high power. It is. That just leaves us to do the deviation on the test set behind me, which I've forgotten to turn on. That's not stupidly hot either. I did make sure it was got some fresh heatsink compound on it. Okay, well, we'll plug into the other test set, but I might have to take a break because I think it takes 10 minutes to come up to the kind of temperature where we can trust it. So deviation is the preset there. Okay, so a couple of days later it's still clogging my bench up. What we've discovered was two things. So this is going to be part one. Hopefully the part two will be very quick, but you never know. Two things. When I tune this up on the external power supply, absolutely fine. When I put it on its internal power supply, we get a hum at 3.5 watts. If we drop the power to 3.4 watts, then that hum disappears. So, looking at the current consumption, 1.1 amps is 3.4 watts, and about 1 amp is 3.4 watts. So it tells me that this power supply is not wanting to deliver more than 1 amp. Now, these regulator ICs aren't an ordinary 7812. When we look at the square kit diagram, I need to have several pairs of glasses here. It's a L78S12. So I'm just going to go and look that up. Okay, so I've looked that up, and it's a 2 amp regulator IC, because normally 1 amp, as you'll all know, is into electronics. There's 7812, 7815, different voltages, 7805 for 5 volts, and so on. So that should be a good choice. But when I look at it, and it's never been changed, it says L, which is the brand, is it Signetics, that one? It's 7812. It does not say anything else. It doesn't say an S in it. So I reckon that's a 1 amp one, and that's one of the reasons. Now, when I've applied 12 volts to the output of the bridge rectifier, and I'm still getting that. Now I'll start again. I applied our voltage from the power supply, which is a 3 amp rated power supply, to the input side of the regulator, and I didn't get a voltage drop when we hit transmit at 1.1 amps, whereas with the power supply built in I'm getting this hum. So at the end of the day, it's all 40 years old. These power supplies run 24/7 whenever these are plugged in, because there's no on and off switch for the power supply. So what we've done is a 7812 CV, is it? There's a 2.4 amp one available on the industrial market through RS Components. I've ordered one of those, which is, as I understand it, the highest current available for the 7/8 series of regulator IC. So that's going to come. And when I look at the bridge rectifier here in the circuit, it says S2Y810 or something like that. I won't be surprised if that 2 means 2 amps. Now, it should be well on top of the job, what's in, but again, back to the same story, it's 40 years old. So I've also ordered a 3 amp bridge rectifier. So when those arrive, we'll complete the rebuilding of the power supply, which will be more tonker than it ever has been. Now the other issue is I've got low, let's put this set on. I'll tell you what, I'll do it via the power supply. That'll do for an earth. And the on and off switch will do nicely for hot. Remember to run it at 12 volts and not 13.8. There we go. So when I look, I can't really show you this. I'll tell you what, we'll put my walkie-talkie on. Transmitted audio is too low. So if I just turn around and tell you what the deviation meter says on the test set behind me. Wow. Yeah, it's about 1. And if we listen to it on the walkie-talkie, testing 1 2, testing 1 2, testing 1 2. It's very the phrase is 10-1, isn't it? To keep it in CB terms. So I have just made up a brand new test mic for some obscure. I went to label this and got waylaid. The dealer this belongs to asked me for a Uniden service manual. I sent him a link for my Uniden service manual and forgot to label the microphone. So it's the owner, the dealer for this set, which has waylaid me. It's all his fault. Testing 1 2, testing 1 2. 1 2 1 2, testing 1 2. Wow! Got 1.5 deviation on that mic. Now, I think I've got deviation at full on this radio. So this isn't good. Wallow. Wallow. So we've got a problem with transmitted audio. And that is a problem because, to be quite frank, I don't want to work on these sets. The printed circuits are awful. So I don't take on repairs where it needs things changing for these. I don't mind doing a tune, but not repairs. So I'm going to have to now do a repair because I was so far into it financially. So it's surely going to be a capacitor which is causing this problems. So it is either pin 1 or pin 3. I think it's pin 1. It's going to be pin 1. So capacitor 80 could cause this to be low deviation. I'm presuming that is deviation, looking at where it is in the circuit. It says R84, but is that one? So it's a matter of changing capacitors till it clears the fault, and I'm going to start at capacitor 80. So there's a possibility of 81, 79, 78, or the whole 9-volt rail could be being affected if that 77 is playing up. So we need to get more audio, but these sets are horrible to work on. What I've done here is I've got a first generation scan of an instruction book. So we've got an enlarged page here, then I've enlarged the enlarged page. Let's see whether we can actually see. The first one I want to look at, which was C80 1 microfarad. So R84 is the deviation preset, as I suspected. 79, 78, 80. There it is. Just get that disconnected. So would be great if it was screen printed like any of the other makes. 79. I saw it once and then I've unseen it. Oh yeah, it's that one. 80, just there. 81's the lower one. Right, I'll go out of record while I faff with this. Right, so here we are, we've got that one in. So let's see. Managed not to destroy the one that I took out. I think sometimes components can be damaged if people have miswired mics. .82 is fair enough. Let's see whether it's made any difference. I'll swing around and look at the deviation meter behind me. Well, you know what? It has. It's 2.5. Testing 1 2. Testing 1 2. Testing 1 2 3.
1 2 1 2.
So that's still full deviation. 1 2
1 2 1 2 1 2 1 2 1. Well,
yeah, it's still full deviation. So, you know, I think there's going to be others. So back to the squirky diagram. I mean, that would be acceptable, but see whether we can make it super duper. Yeah, it probably takes 20 minutes to do each one. Excuse me. So we've done that one. And 78 is also really going to affect it. So that's that one. It's coupling from one stage to the next, so I think we go for 78. So we've done. Have I got one of those highlighter pens on here? No, Mr. Tango, you haven't. So 80 was that one. And what? Actually, I can't even remember what I said. 80. I think that says 78. In which case, 78 is that one. And if that one happens to be, should be the second one down, which is that. That's also 1 microfarad. Anyway, that's what it is. So I'll do this one. Okay, so what I've done, I've ended up changing all the 5 in that speech processing circuit. 1, 2, 3, 4, 5, including the 100 microfarad one. One of the 2.2 microfarad ones actually came out reading faulty on the test meter, and it was, every one of them's made a difference, but that's the last one I've changed. This one, capacitor 79, was actually faulty. So if we listen on the walkie-talkie, testing 1 2, testing 1 2, you can hear there's plenty of gain on that mic. So now we'll go over to the deviation meter, and if I just turn round, we can probably set the deviation not at full. There we go. I don't know whether Mr. Chippie's going to be hearing me in another room. Tango 21, Mr. Chippie, do you copy? Mr. Chippie? Yeah, just testing this radio on the bench.
Yep, roger, working. I would say the audio's tinny, loud.
Oh yeah, I'm not here to do. Right, I'm going to go to the factory mic. I'm on the standard replacement.
Yep, roger.
Right on the factory mic now.
Not as tinny, but it's a bit hollow.
Yep, Roger. Anyway, I found which capacitor it was, and that's fixed.
Roger D.
You can go back to sleep now.
Tango 21, testing 1 2, testing 1 2.
Yep, that's brilliant. And I look at the deviation on the factory mic. Wow. Yeah, that's 2.4 there. So there we are. Right, so we can't go any further. Waiting for parts. Those have now come during the course of today. But what I don't want to do is to take this, you've got to split this, and it's a right faff, so we'll leave it for another day. So we'll end this at part 1, and you'll see where we've got to with it. I can now produce the clipboard and write but I think you can see it's a lot of faff on these sets with the way the printed circuits are. We did that, and so I'll turn this off, and then we can take that clip off, and then I can rest on there. So 2 times 1 microfarad, 2 times 2.2 microfarad, and 1 times 100 microfarad. So it was capacitor 80 and capacitor 78. It was capacitor 79 and capacitor 81. And then, just in case, it fell on the floor, so I never did get to read it, 77. These have all been Nikon capacitors, the highest grade available, so it's going to be as good as it's going to be. So we've just got that hum to sort out. I could do what they did and turn it down to 3.4 watts, but we're not, because the radio is capable of 3.5. So this is not the regulator it says in the service manual, but this is a factory original. So that is, to my mind, a 1 amp regulator, and I think that's a bit of a skank. It says it should be the 2 amp variety, that's the 1 amp one, and on top of that, I'm not quite sure what an S2 V810 is, but either the 2 is going to be 2 amp, or the 10 in that bit is going to be 1 amp. That's my feeling anyway. Anyway, what we've got is a 3 amp one on order. I've got all the microphones covered in papers, and so everything I've said will no longer be muffled because I've just taken all the papers away from it. But there you go, long and drawn out, but with there'll be a part 2, and we'll get that done. So thanks for watching so far with the DNT B40 from 1981.